In previous class, we seen how to assign number of cores to application, right? In previous class, we seen how to assign number of cores to application. Okay. So today we are going to see practically how to assign and how to create, how to load file. Yep, I'll show you. So here I'll assign number of core processors, and next we'll discuss what is partition and what are the operations we apply on partition. Okay, so we'll see all these things in today's class. So let's see. I'm going to start my Hadoop cluster. So I have already installed Cloudera in my machine. So I'm going to access this HDFS file from Cloudera system to IntelliJ IDEA. So before going to start application, let's import the packages and create a SparkContext. Let's start console. Okay, let's import org.apache.spark.underscore. So dot underscore means all classes presented in this package. Next, val sc equal to new SparkContext, and I'm passing new Spark configuration object, and I'm setting 1 minute Spark configuration object, and I'm setting dot set spark dot app dot spark dot master, and what is master name? Local, and star means all processors. Okay, dot set. I'm setting Spark application name, spark dot app dot name, Spark core app. So close set and close context object. It is going to create Spark context object. Next, sc dot set log level. I'm setting log level equal to warning. Okay. Now load file into Spark. rd1 equal to sc dot text file. And here we pass path. So we path HDFS file system path. Let's start putty. And this is my Cloudera system. Let's click on open. Yep, Cloudera. ifconfig. So this is our IP address 192.168. 192.168. So http hdfs colon slash slash 192.168.1.102 colon 8020 slash we created a separate directory, right? Let's open a name node URL 102.5.0.0.70. Under this, we created one directory, utilities. Yep. Here we have a Qt. Qt has log data, log underscore data. Let's copy slash Qt log call underscore log underscore data, right? Slash Qt slash call underscore log underscore data. Okay. Let's press enter. So it is created object rd1 dot count. rd1 dot count. If it is successfully connected, it displays number of records of that one. Let me open browser. Let's open Oreo. So here it's showing live nodes one. So click on this live nodes. One time go to our Spark application. Check. Let's ping. It's pinging. Yep. Let me resolve this one. Why we are getting this error? Let me once again go and find. We are getting same error, right? Yep. I have another cluster. Let me use that one. Here I have master. Let's load this one. Yep. I'll resolve that issue tomorrow class, and I'll clearly tell you why we got that error. Instead of spending time to resolve that issue, let's use another Hadoop cluster to connect through our application. Okay, so this is my Apache cluster. So let's open this cluster 192.168.1.106.50070. So still it is starting. Once it is successful, then I will show you that one. Let me connect WinSCP and place our car log file into this uh, Hadoop cluster. Yep. So let's refresh this one. So this is my name node URL. Okay. So this is utilities, browse file system. Okay. Here I want to create one directory. Let's create Hadoop fs -mkdir and my directory name is /qt. Qt is my directory. Let's use WinSCP and place call log file into here. 192.168.1.106 Hadoop and username is Hadoop and password is Hadoop. Okay, I have some files, call log file. So I have call log data and some other data. So I'm placing this data, uh, call log data and concert log data, and I'm placing into my Hadoop system. So let's open browser, refresh. We see Qt, right? Under Qt, we don't have any files. Once it is successfully placed, now I'm typing command Hadoop fs -put and file name is call log data. I want to put this one under root under Qt. Okay, let's open browser. Let's refresh. So we see call log data replication factor is 2. Okay, so block size is 128 MB, but file size is 82 MB. Okay, so in our application, use this path, copy this path, and go to our Spark application. Here, use instead of this one, use 192.168.1.106. So this one is call log data, right? Call log data. Press enter. So next rd1 dot count. Let's stop and Let's start. Let's start console. Yep. Let's import package. Let's create SparkContext. Let's set log level. So it's creating SparkContext. Once it is created and we are setting log level, then I'm loading file from HDFS path to RDD. Now RD1 dot count. RD1 dot count. RD1 dot RD1 dot take of 3. I want to display 3 rows. Yep. Uh, let's create a Spark context here. So what I'm doing, I'm using just instead of star, I'm using local. Set log level. Let's create load and let's execute take. Let's open this web UI port. This is web UI port. Copy and open in browser. So this is web UI port. Let's expand this one. No, there is no processes started yet. Let's go here. Let's go Cloudera. Right click on this Cloudera and go to settings. Go to settings and go to process. We have assigned 2 process, right? Super. Still it is giving error. IF config 1.102. Let's resolve this problem and I will show you how to connect HDFS file system and access HDFS file into our application. Yep. Let's write this application. So here what I'm doing, instead of this one, what we are doing, we are connecting to HDFS colon slash slash IP address is 192.168.1.1.102, right? 102 colon 8020 slash qt slash call underscore log underscore data. Let's export this one. Yep. Println rd1 dot count. So before that, what I'm going to do is just give me a minute. Here, right click on this one, go to settings. Yep. Let's check one time if config. So we have two IP addresses, 101.102, and another one is 173.142. Let's copy this one and let's ping whether this IP is pinging or not, whether we are able to access this IP or not. So we are able to access. Let's use this IP in our application. Okay, let's save. Let's rerun this one. me check hosting. We are able to access name node. Yep. One more point here. Let me check PC properties. So this is my Hadoop system. So this is the IP address of this Hadoop system. And let's go name node URL. In this name node URL, go to utilities, go to browse file system. Here we have a Qt directory. Under Qt directory, we have files. Cancer data 10, call log data, comment. These are different files. I want to load call log data. So for that one, what I'm doing, so this is my Spark application. Let's open SBT cell. Let's open SBT cell. Let's start SBT, Scala SBT cell by typing console command. So it is started. Next one, import package. Import org dot apache dot apache dot spark dot underscore. Next, to create spark context. Val is equal to new spark context and pass new spark configuration object and set master name spark dot master. Here master is local dot set spark dot app dot name. Spark application name is Spark Core App. Okay, that's it for Spark context creation. It is going to create a Spark context object. Yeah, it is creating. So once Spark context object is created, I'm setting log level. Set log level, and I'm passing parameter is 1. So it display warning messages. Now I am creating RDD val rd1 equal to sc dot text file sc.text file and path is htfs colon slash s and IP address. IP address is, let's copy IP address ifconfig. So this is the IP address of IP address. So this is the IP address colon 8020 slash qt slash call log data call log data. Now rd1 dot count. So we got count. Now rd1 dot take of 5. Take of 5 rd1 not rd1 dot take of 5. So it displays 5 records. Take of dot for each of println. Then it will print line by line. So this is 5 records. So now we are able to access HDFS file system data into Spark application. Only one thing what happened in yesterday is I did some network configurations in Cloudera system. That's why IP address is not recognized properly. Other than that, nothing. Yesterday, whatever we did same approach only. Nothing has changed. Only one thing, I resolved that network issues. Okay. So in this way, we can connect Hadoop system through the Spark application. Okay. Yep. In previous class, we are seeing partitions, right? So partitions means it will create equivalent partitions for every block. So for every block, it will create one separate partition. When you submit, yeah. So that is master. We are assigning cores, not for process partitions. So we are assigning number of cores to Spark application. Okay, number of cores to Spark application. Here, see, first of all, what is partition? While creating RDD, we can create RDD. You want to see whether it is going to work or not. So I'm assigning 2, right? Let me see the syntax. Yep, already SparkContext is running. That's why it is giving error. So let me stop for the sake of you. I'm stopping and showing you. Let me see. Type console. It should work, Prasad. You can allocate any number of processors to any number of cores to Spark application. That is ability of Spark, not our creation. Okay, let's see. So what I'm doing, I'm creating Spark application. Let's see, Spark core. Yep, we need to import one package. Import. Now create a Spark application with the 2 processors. So successful, right? Now val rd1. Let's set log level. sc dot set log level, and log level is warning. Now I am loading file. I'm loading file. Now I am executing count. Okay, working, right? So we can allocate any number of cores to Spark application. Okay, we can assign any number of cores, but cores must be presented. Without cores presented, we cannot allocate. So if cores are not presented, then it will allocate default value. Okay. Next one, see what is partition. Partition means it's a small piece of data, chunk of data. It's a chunk of data created out of data of the storage system from which Spark application reads the data. So Spark can read data from HDFS file system, data from local file system, data from S3 bucket, data from any file system storage, right? So Spark can read data from any storage system. So we can create multiple partitions to your data. We can create multiple partitions. What is partition? It's a chunk of data. It is a chunk of data created out of the data. We can apply operations, various operations on partition. So first, how many partitions? We want to know how many partitions are created for our file. So here, let's see, there is one function called rd1 dot get num partitions. Get num partitions. It will display number of partitions allocated for number of partitions are created for our file. So here it is showing number of partitions are 2, but we didn't specify any partitions at the time of file loading, right? We did not specify number of how many partitions we want. How it is created 2 partitions based on the master. At the time of master creation, we specified number of cores, right? That's why it is created 2 partitions. If you want number of partitions for your file, while loading, we can specify. I will show you how to specify number of partitions, so that according to your value, according to your specified partitions, it will create partitions. Okay. So what is the advantage of a partition? We can achieve parallelism. We can achieve parallel processing. There is no default partitions. If it depends upon the file system. It depends upon the file system. If the file system is HDFS file system, for each block it will create equivalent partition. Okay. So one important point is the number of partitions created depends upon the storage system or the Spark configuration. It depends upon the storage system or the Spark application configuration. So if the storage system is HDFS file system, then based on the number of blocks presented for that file system, so it will create a number of partitions, or we can specify number of partitions in Spark application. If the storage partition is HDFS file system, the number of partitions are equivalent to unique blocks. So if you have file has 3 blocks, it will create 3 partitions. If the number of blocks are greater than 1, the number of partitions are greater than 1. The default number of partitions we can set in Spark application. The default number of partitions we can set in Spark application while loading file into RDD. We can specify number of partitions. Okay, this is one. Next one, how to find number of blocks of a HDFS file system. So we use Hadoop fsck -blocks and directory file name. It displays number of blocks of your file, right? It displays number of blocks of your file. So my directory name is under root qt. Under root qt is a directory name. It will display number of blocks of your file. fsck is a command. It displays number of blocks of a file. So it gives some information. Here we see number of blocks, total blocks are just one. Total blocks are just one. Okay. If number of blocks are more, then for each block it will create equivalent partition. Okay. So here how to specify number of cores. So in master specifying, if master URL, in master URL we specify local of 2 means it will assigns two cores to your Spark application. If you specify local of n means n number of cores. If you specify local of star means all the cores of your system is assigned to your Spark application. All the cores of your system is assigned to your application. Okay. One partition is created for one core. So previously we created two cores, so that's why it is created two partitions. In my mission, my system is a i7 processor, 7th generation, and 4-core processors. 4-core. So by default, two cores are allocated to Windows system. I have only two. So if I given star also, it will allocate only 2-core processors. 2-core processors. That's it. It cannot assign more than two because my system has just 4-core processor. Currently, we are getting 8th generation processors with 8-core processors, 16-core processors. So you can select processors based on your requirement. So at the time of my system buying, I have 7th gen, i7 and 4-core processors I chosen. That's why if I start this mission, Windows it is allocated to two cores. We have only two left. That's why two are assigned to my Spark application. Even if I use star also, it allocates maximum of two. Maximum of two. Okay. Next one. How to know the number of partitions? There is a function called getNumPartitions. GetNumPartitions. RDD dot getNumPartitions. It will display number of partitions allocated for your RDD. So we have four types of partitions: random partition, hash partition, custom partition, range partition. Hash partition, hash partition, hash partition, random partition, custom partition, range partition. The default one is random partition. So we have random partition. And we can create partitions by using we can create partitions at the time of file loading. We can specify how many partitions we want to create. We can specify, and we have one method called repartition method. So if you already allocated two partitions, you want to increase number of partitions. You want to increase number of partitions. There is one repartition concept. By using that repartition concept, we can create, we can add more partitions to your RDD. Let's see. I want to read drop records from call log data. If you observe call log data, this is my call log data. Next, call log data. If I print call log data, this one. If I print 5 records, if you observe 5 records, these are different data. In this, we have one string called dropped, success, failed. So we have 3 types of status. From this file, I want to only drop a record. From this file, I want only drop a record. For that one, we use filter operation. Filter operation. So first what I am doing, uh, I loaded file into rd1, right? rd1 dot filter. Filter command reads each line of your RDD and passes to X variable. In that X variable, I am checking X contains dropped. So if it returns true, then it will create all these drop records and return to another RDD called RDD2. So let's execute this one. What I'm doing, val RD2 equal to RD1 dot filter. RD1 dot filter X implies X dot contains dropped. Okay, X dot contains dropped. Spelling is corrected. Yes. So it will return only columns which has dropped. Its contains. Okay. Now first RD1 dot count. All the columns, right? RD1 contain all rows. 823741. Next RD2 dot count. RD2 contain only drop records, right? So drop records are 104642, right? 104642. Remaining are success and failed. So by using filter transformation, we can filter the data based on query string. Based on query string, we can filter the data. It will return only matched records. Let's once again print this. Let's print all the some results of RDD2. So what I'm doing, RDD2 dot collect dot RDD2 dot take of 5 dot for each of println So we got only drop records, right? Dropped records. We got only drop records. Print only phone numbers. So assume this is my data. If you observe this data, these are phone numbers. So if you observe, this is space, right? Based on space, I want to split this data. So first argument is 0th argument is data and first argument is phone number. I want to display only phone number. For that one, I am writing query rd1 dot map of X implies X dot split based on space. It will return RDD3. Then once we got RDD, right? From this, we want only 4 numbers. So R3 dot map X implies X of 1. So this split is returning array, right? From array, I want 1, means second index value. Then if you print these values, we get all 4 numbers. Let's execute this command process. So rd1 dot rd1 dot rd1 dot map X implies X dot split. I want to split based on space. Based on space. It will return RDD, right? Val RDD3 equal to RD1 dot split. Let's print RD3 dot take of 5. Take of 5 dot for each of println. So we got array. So this is string array. From this we want second argument, right? So let's take val rd4 equal to val rd4 equal to rd3 dot map of X implies X of 1. Next rd4 dot take of 5 dot for each println. Observe, we are getting only 4 numbers. Once we got right, let's save this data. Let's save only 4 numbers. How do we save? rd4 dot save as text file. We can use save as text file. Save as text file, and we can store this file output data into specified directory. You can save local file system, or you can save into HDFS file system. We are reading data from HDFS file system, and we can save into same storage or different storage, right? So destination may be HDFS file system, destination may be local file system, destination may be Amazon Web Services S3 bucket, anything. Here what I'm doing, I'm saving into local file system. So phone number, just I'm giving name, phone number. Let's execute this one. Sorry, single quote. Let's execute this one. Okay, let's go rd4. Sorry, desktop, quality thought, Spark applications, Spark and Scala, batch 3, workspace, Spark core. Here you will see phone number directory. Under phone number directory, you will see part-files. Let's open this one. So two partitions, right? It is created 2 files. If it is 2 partitions, it will create 2 files. If you want to create only 1 file, we go for different approach. If you want only a 1 output file, we go for different approach. So because of 2 partitions, it is created 2 output files. 2 output files. Okay. How to create a single file instead of multiple output files? There is a function called coalesce function. So instead of creating output files or multiple output files, we can specify how many files you want to create. by using coalesce function. Then it will create specified number of files. Let's use this function. Coalesce of 1 dot save as phone number 1. Let's execute this command. Go to output core phone number 1. Under phone number 1, we see only one part file, one part output file, one part output file. Okay. So if you want only one output file, we can use coalesce function. We can use coalesce function. Okay. How to change number of partitions? How to change number of partitions? There is a function called repartition. There is a function called repartition. By using repartition, we create a number of partitions. We can create number of partitions. Let's repartition. First of all, let's see how many partitions are available for RD4. RD4 dot get num partitions. Num partitions means the number of partitions. So we have 2. So RD4 dot repartition of 5. Repartition of 5. Now RD4 dot get number of partitions. RD4 dot get number of partitions. Still it's showing only 2, right? Yep, only one thing, this is immutable. We forgot RD dates are immutable. So what we have to do, after repartition we have to assign RD5. Now RD5 dot get num partitions. Get num partitions. So we have 5 partitions. From 2 partitions we created 5 partitions. Okay. So by using repartition concept, we can change number of partitions, or we can modify partitions. We can decrease or we can increase. Coalesce can be used to merge multiple output files into single output file. Coalesce is a function which is used to merge multiple output files into single output file. But repartition is used to change number of partitions. Get num partition is used to display number of partitions of RDD. Do you have any queries up to now?